Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's see how you did on your homework. Problem number 116. Your job is to identify the following numbers as either rational or irrational, and if it is rational, show that it can be written as a fraction. Okay, because that is the definition of rational numbers. So the square root of 36, since 36 is a perfect square, the square root is going to be a nice round whole number of 6, so that makes it a rational number because 6 can always be written as the fraction of 6 over 1. So it's a rational number, so that makes square root of 36 a rational number. 0.62 repeated literally means 0.626262, and we had learned that rational numbers can be written as either terminating decimals or repeating decimals, which both can be converted into fractions with integers in the numerator and denominator. So in the lesson, we had learned that 0.62 repeated is like 62 over 99. I could go through and show you the algebraic process, but this one actually fits in with that pattern that we had learned with problem 104, I think it was. So most of you probably can see that that is going to be 62 over 99. Now, if you wanted to prove it, that it's 62 over 99, go ahead and pull up the calculator, take 62 divided by 99, and see that you get, yes, 0.626262, repeating. So that's a rational number because it's written as a fraction. This, however, is irrational, can never be written as a fraction. And I say that is, yeah, it can be written as a fraction because all you have to do to make anything a fraction is give it a denominator of 1, but that is not an integer. Rational numbers have integers in the numerator and integers in the denominator. Since that's not an integer, that doesn't make it a fraction, that makes this rational. So this is definitely going to be irrational. This is a number that's going to be between, what is 8, 9, I think it's between 9 and 10. Because 81 square, or the square root of 81 is 9, and the square root of 100 is 10. It's probably going to be like 9.6, 9.7. Let's see what it is. 92, find the square root of that, and it rounds up to 9.6. That's right. So this is definitely an irrational number. For problem 117, remember the equal values method. There are certain situations where you might have two different rules that apply to the same situation, where x and y represent the exact same thing. And the intersection point of these two lines that are created from these two equations has special meaning. -1 has meaning in the context of whatever these rules stand for. So we could use the equal values method if we don't want to go through the trouble of graphing each one of those and finding the intersection point. And the equal values method, you may recall, says if y is equal to this and y is equal to that, then this has to be equal to that. So we'll set this up as an equation and we'll solve for x. I will add 3 x's to each side. I will take away 1 from each side, and that ends up being a -5. So 5 times x equals -5, which means x has to be equal to -1. So using the equal values method, it tells you what x is, but you still have some more work to do to figure out what y is equal to. So take either one of them or take both of them. If I plug in the -1 here, then 2 times -1 is -2, and -2 plus 1 is -1. So that means that y is going to be equal to -1. Here we're stuck with a situation where we've got fractions. We don't necessarily like working with fractions. So if we can rewrite this equation using fraction busters so that we don't have to worry about fractions anymore, it'll make it easier to solve. So I'm going to choose to multiply everything times 6. So every single term on both sides of the equation gets multiplied times 6. So 1/3 of 6 is 2, so that becomes 2 x's. 6 times 4 is 24. And on the right side, 1/2 of 6 is 3, so it becomes 3x. And then 6 times -2 is -12. So this is a much easier problem to solve. I think I'm going to add 12 to each side. Then I'm going to take away 2 x's from each side, and that means that x is equal to 36. So what is 1/3 of 36? I believe that's 12, and 12 plus 4 is 16. Half of 36 is 18, and 18 minus 2 is also 16. So we see that x is equal to 36 and y is equal to 16. So those are the solutions for these two systems. All right, for these two questions related to this rule, we need to remember that y equals mx plus b is the generic formula for any two variable equation, where you've got a slope ratio or a constant growth rate that gets multiplied times x, and then the b is what you get when x is equal to 0, y is equal to that number. That's why we call it the y-intercept. So if I were to rearrange these, the -3 is being multiplied times the x. So if I were to rewrite this, I could write it as -3 times x plus 6, because that's a positive 6 being added to that. It doesn't matter. We can just rearrange the order. And now you see our y-intercept is at 6. And so if you just wrote it that it was 6, that's totally fine. You didn't have to write 0, 6. I just wrote it as if it's the ordered pair on the graph where your line is crossing over the y-axis. It would cross where x is equal to 0 and y is equal to 6. Slope ratio, every time x increases by 1, the total value goes down by 3. So that's the slope ratio is -3. Here we go. Here's a different kind of a nonlinear graph. It's a square root function. It says make a table and graph the rule y is equal to square root of x minus 2 that includes x values all the way from -1 to +10. So that's what I did is I created a table of values, and I created one side for x going from -1 to 10, the other side for y, or yeah, I guess this would be y is equal to this. So the square root of x minus 2. So when you plug in the -1, the 0, and the 1, notice what you get here. None of those are real numbers. You cannot take the square root of -1. You cannot take the square root of any negative number, because by rule, a square root is whatever number you multiply times itself to give you that perfect square. And there's no way you can multiply a number times itself and ever get a negative answer. So these are not even real numbers. So we can't graph them. So the lowest value for x that we can have starts right here. And the lowest value you can have for y is 0 for this particular function. So the square root of 0 is 0, since 0 times 0 is 0. Square root of 1 is 1, since 1 times 1 is 1. And then I go to some of the other perfect squares. And so here's the 0. Here's the 1. Is that right? When x is equal to 2? Yeah. When x is equal to 3, that gave us the 1. And so maybe I'll do this one. When x is equal to 4, we got... No, when x was equal to 6, we got the square root of 4, which is 2. So that's this point right there. And is there another one that pops up there? I guess all the others. So if I were to highlight all of the rational numbers here, I guess this ends up giving you a rational answer. This ends up giving you a rational answer. And those are, oh, and this one gives you a rational answer. But you kind of want to estimate these other square roots so you can get an idea for how the line is curving over the life of this graph. So you don't want to just plot the 0, the 1, and the 2, because that's not going to for sure show you the full curvature. All right, Dawn drove 420 miles in 6 hours. If she maintains this speed, how far will she go in 7.5 hours? Okay, you could set this up as a proportion. What do you multiply times 6 to give you 7.5? I would prefer to change this to a unit rate. I would change this to 70 miles in 1 hour. That's the unit rate. And so you can write this as y is equal to 70 times x. And then what do you multiply, if x represents the number of hours, 70 times 7.5 is going to give you 525. Or use proportional reasoning here. You can cross multiply. You're still, any way you do it, you're going to be multiplying 70 times 7.5. So unless you did this, and I'm just curious, what is 7.5 divided by 6? If you had multiplied 420 times 1.25, you would also get the answer. There you go. And then the last problem is a 5D process kind of a word problem. You got 4 days of the week here. What is this about? The attendance at the county fair was lowest on Thursday, the opening day. On Friday, 5,500 more people attended than on Thursday. Saturday doubled Thursday's attendance, and Sunday was 300 more than Saturday. Okay, well, I'm noticing that a lot of these are being compared to Thursday. So I think it's prudent to make Thursday our X. So Friday is X plus 5,500, and Saturday is 2 times whatever X is. The only one that gets a little bit tricky here now is Sunday, which is being compared to Saturday. So if it's 3,000 more than Saturday, then we'll take 3,000 plus the 2X, or 2X plus 3,000. So let's put all these in. There's the Thursday, there's the Friday, there's the Saturday, there's the Sunday. You combine like terms. So 1, 2, 3, 4, 5, 6 X's, and then 8,500 is equal to the total attendance for the entire 4-day sequence was 36,700. So we'll subtract 8,500, then divide by 6, and that's how you get this number, 4,700, and that's for Thursday. So what are they asking us to declare? It says write and solve an equation to find how many people attended the fair each day. So we've got the answer for Thursday because that's what we got when we solved for X. So for Friday, we have to add 5,500 to this number. For Saturday, you have to double that number. And for Sunday, you have to add 3,000 to Saturday's amount. Now, if we got all this correct, all of this should add up to 36,700. So let's add up all the ones, all the tens, and then 4, 8, 9, 10. That's 17. So I'm going to carry the 1. So it's 4, 5, 6, 7. 7 and 9 make 16. Carry the 1 here. And what do you got? 1, 2, 3. So yes, 36,700. I can check that off and I can declare our answer. And there's the answer in red. All right. So today we are going to get into the Pythagorean theorem and start working on applying the Pythagorean theorem to various right triangles. So good job on your homework. Hopefully you got most of these answers correct or all of them correct. And let's move on to today's lesson.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling